Hey, it's 5-minute physics.
We got a problem here today. We gotta figure out how to use conservation of energy to safely drop a bungee cord with an egg attached to it so it just barely does not hit the ground.
The first part of any great experiment is to create an experimental design. Now first we hung the masses and calculated the difference in the bungee length compared to the mass. Second, we graphed our data in Microsoft Excel 2013 and created a formula using the helpful formula creating software. Third, we applied the given mass to our formula to determine the expected change in y. Last, we calculated the necessary inelastic stretch length, knowing that the change in y could be calculated from our formula. Then we ran our trials.
Because work equals force times distance, we were successfully able to establish a relationship between the force acting on the mass by gravity and its displacement. By graphing these data points and taking the integral of the curve, we were able to determine the work done on the system. This value can be used later in our experiment when we calculate the inelastic string length for our egg drop.
Incoming dope data!
Yeah, we just put that thing in that Excel 2013. It spit out an equation, and so we're like, oh, we need to integrate this. That'll give us the stretch length.
You!
Dang, nabbit. And then from there, we can figure out what lengths of cord of each type, the inelastic, the bungee, and how far it will stretch to where to tie the knot.
Howdy ho!
It turns out it didn't drop all the way. In fact, it came about 32 centimeters short. Yoo-hoo! This was about 85% of our calculated or expected value. Now, taking this 85% into consideration, we can just adjust our calculations and come up with a new stretch length that accounts for the loss of energy, or the 15%. Yoo-hoo!
Cash.
Like a boss.
So, Carl. If conservative forces was all we were looking at in this here equation, we would have been spot on. The GPE, the elastic potential energy, and the kinetic energy all line up in a little pie chart, and it looks real good. But the world's not a perfect place, as I've come to realize in my life, and I just can't win them all, you know. Get that out of the way. Go. We can just cut this part out.
So, since the world's not perfect, we have to take into account some losses, which you'll see here as the red in the graphs, slightly exaggerated for effect. But due to those losses, we were not able to get it as close to the ground as we thought the first time. And that is why the second time we took into account some of those losses, made a pretty good guess on what we should do with using some tricky math that most of you won't understand, and we got it within a millimeter of the ground.
Ooh, kill 'em!